most of the columns, most of the rows. You will bring data from disk to memory whether you need it or not. In columns that, for example, here would be a category or would be store number, they need it. Sales based on state, but it will have to come to memory. Number one will have to be typically walked through all of those columns. So that's why there is a little advice if you want high performance in conventional or row-oriented databases, put the columns that you access most frequently at the front of the row. Now, nice idea, but it doesn't work in practice. Partitioning solves that problem by simply make sure that by design you access only the columns which you need, because every column is separately. By the way, the bit of I/O with IQ is we set it typically in our application to 512 kilobytes, half a megabyte. Single I/O, you may be able to fetch hundreds or thousands or even typically 512,000 dates. So here's a simple example. We'll because we're interested in only in a column state, we'll never touch those other columns which are shaded. As a result of a good compression and efficiency when compression takes place, here's an example of what happens when you take 1 terabyte of input data, ingest it into IQ. So at the bottom, and tables, no indices will probably be compressed to 25% of its size. Then when you add indices that you decide to put on, like high group or low fast or word index or whatever, they're terabytes. So for a total of, let's say, half a terabyte a day. So 1 terabyte became half a terabyte or less. Ignore this top ring called summaries, because we use them in IQ. Then on the right, you have a conventional row-oriented database, which will effectively take the data, ingest it into, and have a base tables, which are roughly the same size as a row data. Then, and that gets really interesting and rich. Could go from 50% increase to 2 or 3 or 5 times increase, and then to get even more performance, things called summaries and aggregates can add a lot of data. So in the end, you're having at least 2 or 3 terabytes, and many times 5 more than the input data. So here the ratio between database and IQ can really be 5 times, 2 times, and actually we have seen all those in the world. Quick slide about multiplex, and especially in IQ 15, 15.2 especially, a very attractive feature. It allows it is this story, so it remained as a concept ideal to what it was from day one. The really good improvement is that now multiple nodes can be writers. Previously in IQ 12, only one node was to be a writer. And here are some numbers for your, I call them limitations, but it's not limitation. So how many rows per table can we have? 280 trillion. We stayed, the biggest one was, I believe, 2 trillion per that made it to be tested. Data size up to 192 petabytes. It's an astronomical number. We are proud of our petabyte test. We are roughly 0.5% of what IQ can do. 5 columns per table. Now that's really interesting because that allows you to keep adding attributes to your table and do not affect the system performance. You can't even dream about this using national database. A maximum number of nodes in multiplex is 12,000, and now each node can be whatever and however big you want it to be. So power, you will never be short on CPU power with IQ multiplex. Then the thing that we'll briefly mention here, which is NonStopIQ, because the question is, once we start growing those IQ databases really big, the question is, how do I back it up? How do I guarantee my SLAs? How do I protect from hardware failure or disk failure, server failure? And NonStopIQ is a concept that effectively keeps multiple IQs, separate IQ instances, in parallel using either IQ level replication, which is not rep server, it's a ingest, or is using a storage SAN level replication and can keep multiple copies, either full copies or delta copies, in a very controlled environment, meaning the secondary copy may be only 5 seconds behind the primary or be 5 hours. It's controlled by the administrator. Can be local, can be remote, so a lot of possibility. This actually is a completely separate training and consulting engagement. Some of the results that we've seen over the last 5 or 10 years, and this is just one sample that we have prepared, speed versus conventional oriented database. Here are some seconds. We could have provided you with probably dozens, if not hundreds of numbers, but they all point to the same ratio. I not 50% or 100% faster. It gets a really difference, talking orders of magnitude faster. It's just one example, and we've been seeing those results in comparisons since 1997. So this is the part where we kind of cause the processing of structured data. We've been asked many times how good in storing data using high capacity big disks. We typically use disks which are 2 terabytes big, so you can quickly show in tens of terabytes of data. A question that we have been asked many times was to store unstructured data. Testing has started in 2003 when IQ lob support has been announced. Let's set the stage. EDMT stands for emails, documents, multimedia, and transactions. And it stands not just for regular emails, it stands for any type of communication between two or more points. Documents and multimedia are effectively the same, only we put them because many times customers ask, well, you support documents, can you put multimedia in it? So we create the term EDMT. And transactions are regular database transactions, which we're all very familiar with. So the landscape. 80% of data is unstructured, it's EM, and 20 is structured. So we have spent all our energy and time developing extremely sophisticated and efficient and fast systems for processing T data or structured data. There are tools which are used to store and search email, documents, and multimedia. Here are some examples. And then also there are products that can store and analyze transactional data, but so far we haven't seen the unit tool to store structured and unstructured data.